My original video about this density graph was using Google Sheets, but since the time of making that video, which was a few years ago I think, Google Sheets has changed subtly, and that change makes it difficult to get a true XY scatter plot here. This seems like an XY scatter plot, but it is not. You see there is no x-axis. These points are just plotted one after the other, with the distance between the horizontal distance between the points the same for each point, which is not what this data should look like. Some people are getting two lines instead of one line, or two lines of dots instead of one line of dots, when they followed the instructions exactly the way I had them in the previous video. So this means that Google Sheets has changed, and we should not use that for the density graph. I'm sorry. Would you please do it over again using Microsoft Excel? And this is how you use Microsoft Excel for this purpose. You take your data here and you highlight it, and then you insert a chart, and here it is, chart, and the chart that you want to insert is the XY scatter chart. And there it is, the XY scatter chart. You could see that the dots are not perfectly aligned, which is the way so the dots should look like this. They shouldn't look perfectly aligned because we took these measurements ourselves, and we are not perfect, and the instruments that we used are not perfect. So you should then click on one of the dots to highlight them all, and then you should right-click on one of the dots and click and select Add Trend Line. And then, this is the trend line, make sure it is linear. You should check the two boxes down here called Display Equation, we need that, and Display R-squared value, we need that. So that's it for the equation. Now I'm going to change the title here. So the title of this is it's density, it is mass versus volume of unknown 2D. This is not the data for 2D. I don't know which unknown this is for, but some kind student has donated this data to me. You don't have to have the title exactly like this, but you do have to have a title, please. Now, to get the other titles, I click on, over here I click on Add Chart Element. Where did I get this icon? I got it from Chart Design Format. All right. Whoops, I'm sorry, not Format. Chart Design. I got it from Chart Design, not Format. Chart Design. I add Chart Element, Axis Title, Primary Horizontal, so the X-axis. My X-axis here is volume, and so is yours in units of ml. If you prefer, you can use units of centimeters cubed. And add Chart Element, Axis Title, Vertical. This is required, folks. You have to have labeled axes. This is the way graphs are made in science. Everything is labeled and titled so we know what the author is talking about. What is this? It's mass. Mass in grams. Okay. So that's it. Now, let me make this bigger so you could see it more easily. Here, this is y equals mx plus b. The density of my unknown is 1.01. I think I only can use 3 significant figures because my volume. Actually, I think I can only use 2 significant figures. Yes, I think I can only go to the. I can only use 2 significant figures because this point. Oh no, I'm sorry. I can use 3 significant figures because I used a ruler to find these volumes, and there are 3 significant figures. So this is 1.01. If I round this to 3 significant figures, it's 1.01. That is the density. The slope of this line is the density. That's an important concept, and the slope of this line is density because slope is rise over run. The rise is mass, the run is volume, mass over volume, that's density. Now, I want you to notice this r squared. It's called the correlation coefficient. The closer this is to 1, the more precise your data is, meaning the more closely your data matches what it's supposed to, the more closely your data matches the pattern that it's supposed to have, right? That's not to say your data is accurate. I mean, they could be matching this linear pattern very perfectly, but still be inaccurate. This just means your the way you made your measurement. See, this number is very close to 1. That means the person who took this data did the measurements very carefully. That's what this means. Now, is this accurate? It might not be accurate. The density might not really be 1.01. Why would there be a discrepancy? Perhaps the tools that were used to do this measurement were biased in a certain direction. Maybe they were giving inflated values or deflated measurements. So there are many different reasons why the accuracy might be off. But what's important here from the r-squared value is that we could see this number is very close to 1, meaning the precision is quite good here. So that's it. Please make your graph like this. Please use Microsoft Excel. If you prefer to use OpenOffice or LibreCalc, some of the free Microsoft Excel like programs, that is okay, but just don't use Google Sheets. If you are a nerd and you like to use Plotly, plot.ly, which is a free graphing program, browser-based, that is okay. You could use plot.ly. The only problem with plot.ly is that it's a little harder to use, a few more steps, and also I do not know how to get the r-squared correlation coefficient on plot.ly. However, you can get the correlation coefficient on plot.ly. That is something that you can do just by Googling that, I suppose. You could see all these extra steps that I had to take to get this line. And here is y equals mx plus b. Here's the m, and here is the b. Remember, the m is the slope, and that's the density. That's what we're interested in. So this is 1.01. I just don't know how to get the correlation coefficient on plot.ly. If you want to use plot.ly, you can, and just figure out how to get the correlation coefficient. The reason why you need to figure out how to get the correlation coefficient is because your density graph has this following requirement. According to the graph, our sample's density is blah, 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 and then you have to say something about, you just have to display. You just have to display the correlation coefficient on your graph, and then you can submit it. Thank you. I'm sorry for the outdatedness of my video. I didn't know that Google Sheets was behaving in a way that is unfriendly to science students now. That is all. Thank you. Please redo and resubmit. Thank you.